Well, now, so this is your basic course in statistic, right? And we will be taking classes on Saturdays and Sundays in two groups for 2 weeks. And so if you want to join any class, you can do so. So suppose, someone want to join with the Sunday class, even after joining the Saturday class, you can do so, right? And I have not yet updated the LMS with lecture notes. මම lecture notes තාම LMS කර දාලා නැහැ. lecture එක ඉවරනාට පස්සේ I will upload all these lecture materials into the LMS, right? So this is the way how it happens. And after the completion of all the lectures, so you will be undergoing a small examination to test the knowledge that you have gathered from this. All right. So let me share the screen for the moment so that you guys can show you up what we will be doing today. Okay. Right. So this is your BFBM course, which you should have taken earlier at the early stage of your work. But anyway, now you are in the latter part of your course, and so we will be doing it because you require this for the completion of your course. But most importantly, it is not the matter. You will need this knowledge, what you gather from this course, for everything what you do in the future. ඔගොල්ලෝ මේ කෝස් එකෙන් ඉගෙන ගන්න දැනුම විභාගේ පාස් වෙන්න නැත්නම් කෝස් එක කම්ප්ලීට් කරන්න විතරක් නෙවෙයි. ඊයෙන් පස්සේ ඔයගොල්ලෝ රස්සාවක් කරන්න ගියාම වැඩක් කරන්න ගියාමත් ඕන වෙනවා. Right? As you know, right, so this is regarding the data analysis, interpretation, and the reporting. And in this context, right, so we will be talking about this with a very low tone, so without so a lot of jargon and mathematical calculations. So I will try to teach you how the statistical methods are used for data analysis, interpretation, and reporting of the data, so that you will be collecting for various purposes. And so this part of lecture so devotes for identification, sampling, and collection of data for decision making. I said you right. So this is required for any work that you do, right? Even now, even today, even tomorrow, even in couple of years time, right? Whatever you require, it's because we make decisions in our whole lifetime. We make decisions in our whole lifetime. අපේ මුළු ජීවිත කාලෙම අපි තීරණ ගන්නවා. For the purpose of making decisions, so we need information, right? So this is the motivation. This is the motivation of can all of you hear this? Okay, this is the motivation why we want to learn this. Why we want to learn this. ඔයගොල්ලන්ට මේ විදිහට තිබ්බම පේනවද මේක? ප්‍රශ්නයක් නැද්ද? පැහැදිලිව පේනවද? මේ ස්ක්‍රීන් එක හොඳට පේන අය chat box එකේ එක දාන්න. අනිත් අය බිංදුව දාන්න. ඉක්මනට. ඉක්මනට responses ඕනේ. දඩ බඩ ගාලා එක්කෙනයි දෙන්නයි. අයියෝ මදි. Okay, that means yes, all of you can see, because I don't want to, put this into the presentation mode because I want to write on this. Okay, so this is the motivation of so doing this lecture. As human being, so we are curious of knowing, right, about the things around our environment, in our environment surrounding us, and we need to get clarifications. We need clarifications. So we have issues, problems, and need solutions. So we need to make decisions. අපිට තීරණ ගන්න වෙනවා. So we need to make decisions. So for the purpose of decision making, we need data. Sorry, we need information for the purpose of decision making, right? So we make decisions on our issues, we make decisions. So with the clarifications, and so we will make decisions looking at what is in the surrounding. So this is key. This is important. For this, to make decisions, right, we need data, need information. So where do we have information? Where do we have information? Information කොහෙද තියෙන්නේ? Eh? You will have information in data, right? So we need data to get information, right? The information and data are two things. Okay. Data includes information. Data includes information. So this is it. So this is the reason why we should learn this subject, data analysis, interpretation, and reporting. And the importance of identification, sampling, and collection of data for decision making is very high, because we make decisions on the data that we have collected, right? Okay, please give me a minute. All right. Right. This is the reason why, right? So we want to learn about this because so if we work with wrong data, the information that we derive from the data is wrong. If we have wrong information, what happens is our decision also will be wrong. This is very simple. So therefore, if you want to make accurate decisions, so we need to use data, so which are accurate, right? Okay, so this is the motivation of learning this. Well, right. Okay, so before talking about this, right? So we need to understand a few terminologies, few technical terms, right? That we work with. So then only you can understand. So what I'm telling to you, right? Okay, so let's try to understand um, the definition of keywords, key terminologies, right, coming under statistics, right, that we require to know in this course. Okay. All right. So what is the surrounding? The surrounding is the environment, right? So what are the things that we are studying on? Identification that is very important, right? So then, so we have a terminology which is called population, right? So what does it mean by population? So usually the people says, okay, population is the human, the everybody, every one of human is the population, but it's wrong. The population is a collection of things that we want to study. And the population is the collection of things so that we want to study. So that means so there is no any any clear definition, any concrete definition on population. The definition of the population depends on depends on what we want to do. So that means the objective of our work. The population is defined by the researcher or the person who is collecting data, right? Or the person who wants to make decision. So that is the person who decides the population. So in this context, so it is very important to define the population, the term population, because it is objective oriented. So for an example, so if you want to study the performance of the students, right, taking DAPM course, right, the population may not be all the students who is doing diplomas, because we want to know only about the students undergoing DAPM. අපිට DAPM එකේ ස්ටුඩන්ට්ස්ලා ගැන දැනගන්න ඕන නම් අපිට වෙන ස්ටුඩන්ට්ස්ලා ගැන අදාළ නැහැ. සරල භාෂාවෙන් කියනවා. So then we will define the population as all the students who are undergoing DAPM. So this is it. Right? This is it. Right? This is it. Right. Okay, let me do a little input, little thing, little change. Okay. Let me keep it here. So we want to discuss things. Okay. One more. We will do it like this. We will take them part by part. All right. The population. Example. Right. Example. Right. All students, right, registered in DAPM, because our objective here is need to know performance of DAPM students. Our objective is this. So we need to know the performance of DAPM students, not anyone else, right? Not anyone else. වෙන කවුරුවත් කියන්නේ නෙමෙයි. අපි ඉස්සරහට කරන්නේ මේක. එතකොට this is the way how we do it. A sample is a fraction of the population. The sample is a fraction of the population. Right? Sample is a fraction of a population. Okay. Why we get samples? Why we need samples? Okay, we will learn, right, later why we need samples. Okay, we will discuss it here. Why we need samples? Say we want to know average income, average production of Sri Lankan paddy farmers. We want to know this. The average production. සාමාන්‍යයෙන් ලංකාවේ වී ගොවියෙක් කොච්චරක් නිෂ්පාදනය කරනවද කියලා. Right? So what would be our population? We define the population as all paddy farmers in Sri Lanka. There are paddy farmers in other countries as well, but we are not interested about them because we want to study the paddy farmers in Sri Lanka. But the problem is the number of paddy farmers more than 10 million. A lot of people. So then it is hard to collect data. From all. It is costly. time consuming. Need more resources. So we need to make a lot of effort. So therefore, it's hard. So therefore, it is very difficult. It is very difficult, right? It is not always easy. It is not, right? It is not always easy. It's not always to collect data from all, right? All in the population when n is very high, right? So then solution, we don't want to give up, right? The solution, get a fraction of sample of population and study. And this is the solution, right? So this is the reason why we need sample. Sample is a fraction of the population that we take for studying. That we take for studying. All right. I hope you can understand. Any question up to this? කාට හරි මේ දක්වා මොනවාරි ප්‍රශ්නයක් තියෙනවද?
But sir, in the case of Sangananedi, but we collect all the data.
Yes, that is different thing that we will discuss later. But suppose you are a company, right, who is distributing seed paddy, and you want to know the requirement of seed paddy by a farmer in a particular area. How do you know it? Are you going to collect data from all farmers in the particular area? No, right? We don't want to do it because the company doesn't like to invest such a big amount of money to get information. Money matters, right? Yes. So in the census, we call census, right? So I will explain it later, right? It's coming later. In a census, right? So we will collect data from all individuals in the population, which is done, right, with a lot of effort, if and only if it is necessary, right? All right. So we'll talk about it a bit later, right? Okay. Right.
Excuse me, sir. සාම්පල් එකක් කියන්නේ එතකොට ඔක්කොමලා නියෝජනය වෙන විදිහට තෝරගත්ත හම්බු නියදියක් කියන එකක්ද?
සාම්පල් එකක් කියලා කියන්නේ a portion of a population. Population එකෙන් කෑල්ල. පොඩි කොටසකට තමයි අපි සාම්පල් එකක් කියලා කියන්නේ. නියදිය පස්සේ කතා කරමු. Right? So that is about representative sample that we talk about later. Simply, a sample is a part of the population. That's all. So there are different kinds of samples, right? Biased samples, unbiased samples, representative samples, random samples, purposive samples. There are different kinds of samples if you talk about the terminology. But in this context, so if you explain, if you define a sample in the broader context, right? We will define a sample as a part of a population, right? Okay. I hope it makes sense. All right. So we'll try to understand this, the term parameter. A parameter is a summary measure computed to describe a particular characteristic of a population using population data. Use population data. Right? For an example, population, the mean of the mean yield of paddy farmers population, right? Paddy farmer population in Sri Lanka. So we will collect the yields of all paddy farmers in Sri Lanka and estimate the average value. So this is called, right, the population mean. This is called population mean. To denote a parameter, right, to signify a parameter, we use the Greek letter. So then, to denote population mean, we use mu. So this is a standard notation. We use a Greek letters to denote a parameter. One example is the population mean of the paddy farmers in Sri Lanka. The population mean of paddy farmers in Sri Lanka. It's one example. So if our population is, right, the DAPM studies, DFPM students, and our objective is to study their performance, right? The average score of this course of DAPM students is the population mean. Because our population is all DAPM students in this batch. If our population is all DAPM students, right? So they are not only the students in this batch, in the next batch, right? In the fourth intake, second intake, and the first intake. So then everyone in your batch is not the population. Everybody who has completed and doing the course will be the population. Right. So that depends on your objective, right? I hope it makes sense. The problem is the estimation of parameters is difficult. Right? The issue is, give me a minute, please. Okay, sorry for the disturbance, right? Now you know, right? The estimation of a parameter is a difficult thing, which takes a lot of money, a lot of time, a lot of resources, right? And there are a lot of issues. So therefore, we will estimate the parameters using sample data. The estimated value of a parameter by using sample data is called a statistic, right? An estimator and of a parameter using sample data is called a statistic. We will use an English letter symbol to denote a statistic, right? Estimator of mu is x bar. So this is sample mean, right? Example. Any question up to this? Okay. So this is the procedure, right? Of collection of data. Okay, there are certain instances that we collect data from the total population. That process is called census. Right? Okay. The estimation of parameters by using sample. So we have different methods of doing it. But one example is survey. We do survey with samples, right? Okay, we take a fraction from the population and estimate the population parameter. To make inference about the population parameter, right? So this is the usual procedure, right, of estimating, right, the population parameters to make inference about the population. So this is in short, right, about the terminology, about the background knowledge that you must have to understand what we will be discussing in next. Any question up to this? Any question? Okay. So if you don't have questions, well, let's move forward. So we will be using statistical methods, right, to get the information out of data. Use them to get information from data. So there are two parts of statistical methods. Right? The first part of statistical method is descriptive statistics. It is about collecting and describing data. Right? So we will give more emphasis on this. And the second part is inferential statistic. So which is about drawing conclusions or making decisions, right, about the population based on the sample data. We will be not discussing this in our class. We discuss this part in our class. Okay, let me further explain. So what descriptive statistics are. As I said, the descriptive statistics are about collection of data, presenting data, and characterizing data. We will learn this part. We will take this part. We will cover this part in DAPM. We will do it. So when we come into the inferential statistic, it is about estimation of parameters and the hypothesis testing. So if you talk about estimations, we have two kinds of estimations: point estimate and interval estimates. Right? And the second part of inferential statistics is hypothesis testing. So it is about drawing conclusions or making decisions concerning a problem based on sample results. So there may be a hypothesis. There may be a hypothesis, right? Maybe a hypothesis. Well, the average yield of paddy farmers in Sri Lanka is 50 bushels per acre. So we want to prove this. Someone may say that, okay, it is 50, but who cares it? We don't know, right? Just because someone tell about it, we will not prepare to accept. Then we want to test whether this value is really 50 or below 50 or above 50. So this is what we will be doing with hypothesis testing in short. All right. Do you have any question up to this? Okay, if you don't have any questions, so please get a 5 minutes break. හැම විනාඩි 45කටම වරක් විනාඩි 5ක බ්‍රේක් එකක් දෙනු ලැබේ. පැය එකමාරක් ගියාම දෙන බ්‍රේක් එක විනාඩි 10ක් වනු ඇත. නැත්නම් 15ක් තේ එකක් බීලා ඉන්න. Right. So please take your first 5 minutes interval. Then 10යි කාලයි 10:20ට පටන් ගන්නවා. Mm. 24 out of 45 is present. What happened to the other persons, other 21 people? තාම ඉන්ටවල්ද? Only 21 are connected me online actively. Oh, now it's 26. What happened to the rest? 28. All right, well, let's move forward. All right. So now in this section, we talk about data. And the first question that I would ask from you is, right, why we need data? First question that I ask you, why we need data? මට කට්ටිය කියන්න පුළුවන්ද ඇයි අපිට data ඕනේ කියලා? Can you guys tell me? Okay.
time management.
We need data to generate information.
Gather information.
Excuse me, sir, we can't hear you.
Sorry about this. කොතනින්ද ඇහුන්නේ නැත්තේ? මෙතනින්ද? මෙතනින්ද ඇහුන්නේ නැත්තේ?
Yes, sir, මුල ඉඳලම අපි after break you asked some question why we need data, then after that we could not hear.
Okay. We will do it again. Very good. Yes. You know why we need data, right? So we discussed it. And there are two different types of data sources. There are two different types of data sources. The first data source is primary source, and the second data source is secondary data sources. Two categories, primary data source and secondary data source. So we will take secondary data source first, right? So they are the data, they are the sources where the data have been stored in printed form or electronic form. They are books, electronic devices, internet. Some examples of secondary sources of data, maybe magazines, maybe research articles, maybe newspapers. So they are the secondary source of data. The data that we take from secondary sources are called secondary data. The data that we get from secondary sources are called secondary data. They are secondary data. They may be either in printed form or electronic form. But don't forget that this data has been collected by someone else for some other purpose. So therefore, you need to be very careful when we use secondary data. So you need to first check whether this data matches with what you want to do. Right? So we need to understand how they have collected data, the purpose, whether this data satisfy requirements, your requirements, by your requirements. So we need to check for accuracy, right? So all these things need to be checked prior to use secondary data. That's the reason why I told you be careful when we use secondary data. Okay, when we come to the primary data, there are many primary data sources. The few key primary data sources are given here, right, on the screen. So they are respectively observation, data from surveys, and data from experimentation, data from sensors. So this data, right? All right. So these are the primary data sources: observation, survey, the data collected through observation, right? Okay, data collection from survey, the experimentation and census. So they will be the primary data, the data that we will collect for our purpose. So these are the primary sources of data, right? Primary sources of data. Okay. Now there are different many methods, many sources of primary data, right? That you will see later, right? The data from sources are primary data. They are the data that are collected by us or for us, right? So these primary data later become secondary data. So secondary source, then they become secondary data, right? Okay, so this is how it happens. The primary data are the data that we collect, right? At the time we want these data. Okay. So these are some examples of data, right? These are some examples. Testing data. So sometimes you might feel that the data are necessarily a number. So you might see that data are necessarily be a number or numbers. But remember that data are not always numbers. So please look at this. So these are some examples of the tasting data. There may not be a taste, there may be little taste, moderate taste, or very taste. So we need this kind of data, we generate this kind of data in a tasting panel, right? So if you go to the tea market, right, there are tea tasters. They do tea tasting and generate data, and they grade, right, different levels of tasting. So they are not numbers. It's sort of a quality, it's sort of a characteristic, it's sort of a symbol, it's sort of a value. The number of accidents taken place in Gold Road on Friday evening. So this may be a numerical value, it's a number. The plant growth, right? The mean annual temperature, household income, right? And gender, right? Male, female, right? Okay, color, red, blue, green. So they have some features, right? There are certain things, right? So they are some examples for data. So it is very important to have a fair knowledge about what data are before you collect them. අපි data කියන්නේ මොනවද කියලා දන්නේ නැත්නම් අපි කොහොමද ඒවා collect කරන්නේ? Right? So we should have a fair understanding about what data are. Data කියන්නේ මොනවද කියලා අපිට fair understanding එකක් තියෙන්න ඕනේ. Okay. Right. So now, so before we collect data, we need to understand different types of data. You see it, right? So these data are in different nature. So therefore, we can classify or we can categorize this data into different classes based on their features. So this is something important you must know before you collect data. Right. So let's talk about the type of data. Let's talk about type of data. Right? Let's talk about types of data. So in the broad sense, we can divide data into two categories, two classes. The first class is categorical data, and the second class is numerical data. And numerical data again divided into two classes. They are called discrete data and the continuous data. Discrete data and continuous data. So this is one classification of data. Okay, let's try to understand what are the categorical data. Categorical data. And qualitative data. They describe some characteristic of a population. By means of a feeling, right? So which can depict it, right? By means of feeling or description. Right? We can denote them by a symbol, number, or picture. But mostly the magnitude of data points are not well defined. Example, gender. Gender is a character, right? So we call this is a variable, right? The values, outcomes of a variable are the data. The values or outcomes of a variable are the data, right? Gender can take two values, or two outcomes, right? Gender can take two outcomes, right? Gender can take two outcomes, gender, male or female. So we characterize the outcomes by words, or else we can characterize them by symbols. Male, okay, male, female. We can assign M for male, F for female. We can assign a symbol for male, a symbol for female. We can assign a number 1 for male and 0 for female. So we can denote or we can signify the outcomes of any variable, as data. The data are the outcomes of a variable, right? The data are the different ways of a feature, right? So they are the data. So one example for categorical data is gender, right? So they can take male or female. Okay, let me come up with another example. Education level. Example 2. So we can denote a variable by a capital English letter. We denote a variable is denoted by a capital English letter. Right? Capital English letter. Education level. So what are the outcomes? What are the outcomes of X? Outcomes of X. High, medium, and low. Right? We can assign letters high, medium, low. So we would assign high for high 3, medium 2, low 1. Right? So these data has some idea about the magnitude, but the way how I define high education level and the way how you define high education level are different. My high and your high may be different. So that's why I say that the magnitude is not clearly defined with these data. They are categories, they are classes. The values of, right? The values of the outcomes of a variable can be signified a simple English letter, right? So we can signify them as x1, x2, x3 likewise, okay? Okay, with a subscript. Okay, well, right. You need, okay, so could you please type one example, right? I want all of you to type one example for qualitative data in your chat box. ඔගලගේ chat box එකේ right qualitative data වලට example එකක් ලියන්න 43 දෙනෙක් ළමයි ඉන්නවා. I expect 43 answers. Yes, please do so. නැත්තම් quantitative. Right? So there are two categories of them. Continuous data and discrete data. So we'll take first, right? So they are the data. They are the numerical outcomes of a variable. There are two types. Continuous data. The first type. Right? Example. Plant height. Measured in centimeters. Right? Production. Measured in kilogram. Body weight. Measured in grams. Okay, so we can come up with volume, right? Speed, the time, whatever, right? But the feature here is so these data are not disconnected. The data, continuous data are not disconnected. Say, so we have measured height in centimeter. So we have one plant 1 centimeter, plant 2 centimeters. So if we take centimeter 1 and centimeter 2, right, we have large number of values, many values, no gaps. So these kind of data are called continuous data. So if I ask you to measure, say if I ask to measure 1 kg of sugar, right? Can you do this? Can you do it? මට කියන්න හරියටම ඔයගොල්ලන්ට කිලෝග්‍රෑම් එකක් සීනි මනින්න කිව්වොත් මනින්න පුළුවන්. Can someone answer me? If I ask to measure 1 kilo of sugar exactly, can you do it?
We can't measure exactly.
කිලෝ එකක් ඉල්ලනවා සීනි. අර පරිදාන තරාදියෙන් කිලෝ එකක් දෙනවා. අපි ඒක අරන් ගිහලා ෆුඩ් සිටියේ තරාදිය උඩින් තිබ්බොත් එහෙම අර ඉලෙක්ට්‍රොනික තරාදියේ කිලෝ 1.3යි කියලා එන්න පුළුවන්. නැත්නම් කිලෝ 1.05යි. ග්‍රෑම් 50ක් වැඩි. ඊට පස්සේ අපි ෆුඩ් සිටියෙන් මැනගන්නවා කිලෝ එකක්. එයා කිලෝ එකක් කියලා මැනලා දෙනවා. අපි ලැබ් එකට ගිහිල්ලා ඇනලිටිකල් බැලන්ස් එකකින් කරපුවාම කිලෝ 1.05යි. So nobody on the earth can measure exactly a point measurements of a continuous data. No point measures, cannot measure, cannot get. Point measurements of continuous data. අපිට ගන්න බෑ. The second type of quantitative data is discrete data. They are not, they are, so these data, the data points, consecutive data points of this data are disjoint. There are gaps. There are gaps between data points. Example. One, number of accidents. Right? Say this is y. Y can take, right, a value 0, 1, 2, 3, up to infinity. Do you have any number between 1 and 2? Do we have 1.5? Can we have 1.5 accidents? There are no half accidents. Accident is an accident. Right? They are not half accidents. So these kind of data are called discrete data. I hope it makes sense. Any question from this? Interval එකක් ඕනද? ඒකක් බිලෙන්න.
Yes, sir.
Everybody? හැමෝටම ඕනද? එකයි ඇහුනේ. What about the others?
Yes, sir.
Okay. So take a 10 minutes break. 11:10යි 11:20ට ආයි ක්ලාස් එක පටන් ගන්නවා. පටන් අරන් දිගටම කරගෙන යනවා මේ පාඩම ඉවර වෙනකම්. Right? මම දැන් මේ පාඩමේ භාගයක් ඉවරයි. Right. Okay. So we'll have a short break. Are you ready? Can all of you hear me? මාව ඇහෙනවද?
Yes, sir. We can hear you.
Okay. We will start the lesson now. Okay. So the second the classification of data is scales of measurements. So which is more coherent classification of data, right? In this context, so we will categorize data into 4 classes depending on these 4 characteristics. The first one is identity, the second one is magnitude, equal interval between 2 consecutive data points, and presence of an absolute zero with the data. So these are the 4 characteristics that we use to classify data into 4 classes. Okay, let's talk about the first one. The first class of data, the first scales of measure is nominal scale. The numbers are we usually use to label the group of classes, or numbers, or pictures, or characters, or symbols will be used to symbolize, right, the data in this class. So these kind of data has only an identity, and they do not have a magnitude, equal interval, or true zero. So I have given here 2 examples. The first example is gender. So we have male and female. The second example is the color of eyes, of eye color. So there are blue eyes, there are green eyes, and there are brown eyes, right? So if you take the first example, gender, if you take male and female, we have recognized so what is male and what is female. But we are not able to order this data. So we cannot order these data either from ascending order or descending order, because these data do not have any magnitude. And there is no interval defined in between male and female. And there is no zero value for this data. So these kind of data are called nominal data. You can see nominal data under qualitative category. Okay, so the second category that we will discuss is the ordinal scale, the ordinal data. So in addition to the identity, the ordinal data has some magnitude, but the interval between 2 consecutive data points of the data in ordinal scale are not well defined, and they do not have a zero value. So these are the examples, these are few examples. The first example is product ranked by customers. The customers rank products as bad products, medium products, and best products, right? The product that I label as bad may be labeled as someone else as medium product, medium quality product. Sometimes a product that I label as best product may be recognized someone else as a bad product. So this is the reason why I would say there are no clear interval between 2 consecutive data points, because the best is defined differently by different people. So with this data, you don't have any zero value, but we can order these things. The best is the highest one, the medium is the second one, and the lower is the third one. So we can order this data. So because of this, right, these data are called ordinal data. The ordinal data carries more information than the nominal data, because so we can have the idea of magnitude. Okay, so let's move to the third class, so which is the interval data. There are some data which has identity, magnitude, and the interval between 2 consecutive data points are fixed. Whether you measure it or I measure, the interval between 2 consecutive data points are fixed. If I measure it as 10, Whether you measure it or someone else measures it, it's 10. But the problem with this data is they do not have a true zero. The true zero of this data is not well defined. The one classical example is the temperature, right? The temperature. If you measure temperature as 10 centigrade, if you measure, I measure, or someone else measure it, it will be 10 centigrades. It doesn't change. The difference between 10 centigrades and 11 centigrade is 1. So this value does not change. But the problem is this. So if you measure temperature and identify the temperature as 0 with centigrades, and if you measure the same by Fahrenheit, that value would not be 0. It's 32, different value. So therefore, the 0 value of this data type is dependent on the scale of or the units of the measurements. So there is no true value for the temperature. Another example is the calendar time. It is not the time, right? It's calendar time. If you take time, it's in a different scale. The calendar time also one example for the data in the interval scale. We don't have much examples under interval scale. So these are the only 2 examples that I could find in my whole lifetime, right? All right. If you take the calendar time is measured in differently. BC, right? Then Hijri and the Buddhist years. So there are different kinds of years. The 0 value for these is different. Right? So these are some examples of data in the interval scale. But these data are quantitative data. These data are qualitative, ordinal data are qualitative, but interval data are quantitative data. The last class is the ratio scale, right? So these data, the data in ratio scale has identity, magnitude, interval, and the true zero. The examples are height, weight, salary, number of accidents, number of pest counts, number of coconut, right? All these things are coming under the ratio scale. They have identity, magnitude, equal interval between 2 consecutive data points and true zero. The zero weight is 0, whether it's measured in kilogram, tons, pounds, like grams, centigrams, the 0 value is 0. It doesn't change. The 0 salary is 0, whether it is measured in dollars, rupees, or whatever, right? Yuan, yen, whatever, the 0 value is 0. So these are the data which has more information. So we can divide ratio scale data into 2 as continuous data and discrete data. Okay, right. I hope it makes sense. I hope now you have a fair understanding about so what is data and why we need data. Is it clear? Any question up to this? Any question up to this? ප්‍රශ්න මොනවද තියෙනවද? No? Okay, if you do not have questions, so let's move to data collection. So we will collect data through many exercises. So some of them are listed here. We can do collect data by experiencing or by observation. We can collect data from a census. We can run a sample survey, and we can do some experiments to get data. So these are some some methods of data collection. Right. Okay, let me talk a little more about methods of data collection. Right. Okay. Observation. The first one. Right. So we will be going to the field. And experience it. Right. The second one is census. Right. Collect data from all units in the population. So this is costly, right? Time consuming, need more resources. When population size is increasing, right? Okay. The other type is surveying, sample survey. Third one is sample survey. Right? We collect data, the process of collecting, right, data from a sample, right, with or without an enumerator. We collect data in this case. We collect data on what has already happened or taking place. No control, not interventions. No intervenes, no experiments. So we do not do anything. What we observe is what is happening through the sample survey. Right? There are different kinds of sample surveys. Types of one type is A, enumerator driven sample surveys. B, self driven. In the enumerator driven sample survey, so we will interview the person who is giving us data. In the self driven sample surveys, the person himself provides the data about him, right? So this is what we do. Okay, right. The second is, the second classification is by the mood. Structured will so let me explain A and B with more details. So if you talk about the enumerator driven sample service, so they are uh, taken through interviews. So we do interviews with unstructured questions, with open questions. Interviews with structured questions. Third one is interviews with semi-structured questions. So we will be doing it in different ways. So sometimes we will interview people, right, without any guideline, with open questions. What is your idea about the prices, market prices of this? So sometimes we will do interviews with, with structured questions. Maybe we will be doing a questionnaire survey. We can have a questionnaire survey, right? We can have a questionnaire survey. We can have questionnaire survey. Participate the survey. Open interviews. So they are examples of enumerator driven service. So we will take the second one. Self-driven sample service. Examples. So one example is telephone survey. Example, mail survey. So we mail the questionnaire or data collection sheet to the informant, and the informant will fill it and return us, right? Then Google search, Google survey. Email. So we send the questionnaire, right, to the informant, and the person will fill it and return to us. So these are some different survey formats that we can use to collect data. The other one is the experiment. The fourth one is experiments. So they are mostly happen with non-human objects, right? So we intervene or we do treatment or changes to experimental units, to sample units, and let changes to happen. Do and experience. So these are the experiments. So we can do, we can use different fertilizers on different crops and see the changes. We can feed animals with different feeds and see the performance. So we can treat animals with different medicine and see the difference. But we can't do so with the human objects. It's hard. The experimentation on human objects is very difficult and very hard and rare. But experiments with crops, animals, and other non-living objects is very common. So we will be collecting data by doing things, by making changes. Right? In experiments, we will be collecting data making changes. This is what we do. Right. So this is about the different methods of data collection. All right. So if we do collect data by different methods, there are few things matters. The one thing, right? Two things that matter is precision and the accuracy of data. What does it measure by the accuracy? The accuracy is the correctness of measured value or nearness to the true value of the particular parameter. So by collecting data, what we are trying to do is estimating the parameters, right? So by collecting data, what we expect is to study or to estimate or to anticipate the population parameters. So we estimate population parameters using sample data. The estimated value of population parameters are called statistics. Now, what we estimate from the sample may not be the true value of the population. If what we estimate is exactly as the true value of the parameter, the accuracy of our estimates is 100%. So, which is very rare, right? So, there is very unlikely to estimate, right, the parameter as exactly from the sample data. Right? The difference between the true population parameter and the estimated value of the parameter is called bias. Right? The one parameter is the population mean. The population mean is if you add all values of the population and divide it by population size, we get the population mean, right? And we denote sample mean by x bar. So it is, right, all total of values of the sample divided by sample size. The difference between A and, so let me change this. I will change it, right? So I won't replace this. I will replace this with this mu. And so this should be mu, right? The difference between mu and x bar is the bias. So then we need to estimate, or we need to collect data to estimate parameters as unbiased as possible, right? අපි estimate කරන්න parameters as unbiased as possible. කියන්නේ අපි sample data ගන්න ඕනේ පුළුවන් තරම් population data වලට සමාන වෙන්න. right? එහෙම එකක් තමයි කියන්නේ. How do you know our measurements are biased? So we will compare with, right, two values. So we need to minimize the bias in our measurements. So we identify the presence of bias, reasons for bias, and avoid them. Right? And avoid them. And we need to avoid other causes, right, of bias, to calibrate the instruments and measurements, and get sample. They are, right? We want to get representative samples. If we have a representative sample, the chance of estimating an unbiased estimate is less. The second concern is the precision. The definition of the precision is a measure of scatter in data caused by the random error. The precision is, right, the repeatability. If you repeat it several times and see the same answer, so that means the precision of our measurements is very high. So if we repeat the experiments and see different other options, the outcomes which are very different from each other, so then the precision would be less. Then the precision would be less. So this is the way how you view the accuracy and the precision. So see, so this is our dartboard, right? And in the dartboard, right, we have in the middle the target. This is the target. So if you hit, right, some arrows, say I have 3 arrows and I have 3 chances, I hit it like this. And another person has got 3 chances and hit the arrows like this. 3 arrows, right? So this is person A. So this is from me, right? So this is person A. This is person B. So what about the accuracy of the work done by person A? The accuracy is nearness to the target. So this person, the person A, is not that near to the target, but person B has hit the darts near the targets. The accuracy of the person B is greater than the accuracy of the person A. So what about the precision? So if you look at the precision, it is different. the precision with person A is very high, although its measurements are biased, they are not accurate, but they have hit 3 times to the same place. So this person's, the precision is higher than the precision of the second person. So this is the way how you pretty much understand the difference between precision and the accuracy. There may be precise but inaccurate results. There may be accurate but not precise results. Right? Okay. So these are the measures of precision, variation, standard deviation, confidence interval, and the coefficient of variability, which we will learn later. So therefore, I don't discuss it. So how do you maximize the precision of our measurement? So we will use careful techniques and make multiple measurements. By doing this, we can maximize the precision of our. The other way we can maximize we can assure precision and accuracy by taking representative samples, right? Representative samples. So that means if our sample represents the population 100%, the precision of our measurements as well as the accuracy of our measurements will be high, right? The problem is the way how we get a precision sample, sorry, representative sample, right? So there should be a way to get a representative sample. But if you look at the populations, so there are different things taking place in the populations. The variability of the measurements of the characteristics that we measure may be sometimes high. So there may be some other factors that influences the variability of our measurements. In presence of this situation, right? So this process of getting representative sample has become very complicated. So therefore, the scientists, the statisticians, the mathematicians, they have suggested different procedures, different protocols to get representative sample. So the protocols of getting representative sample is sampling methods, right? Is sampling methods. So there are 2 kinds of sampling methods. One is non-probability sampling method, and the other one is the probability sampling methods. The difference between non-probability sampling method and the probability sampling method is, so we will select the individuals in the population into the sample, so based on the law of probability by the probability sampling methods, where we give equal opportunity to the individuals to be selected into the sample. So this is the way how we explain the probability sampling. But with the non-probability sampling, we do not do so. It doesn't depend on the probability law. The non-probability sampling depends on how much the person who is sampling has a fair knowledge about the population. So we will be selecting individuals into sample based on our knowledge about the variability of the population. So based on that, so we will select individuals, right, into the population such that it represents the population. But there is no any mathematical or statistical way or probabilistic way of getting individuals into the sample. And there is no assurance that each and every individual in the population get the same chance to be elected into the sample. එහෙම තමයි කතාව තියෙන්නේ. අපිට probability sampling කරන්නේ probability law එක අනුව අපි හැම individual කෙනෙකුටම ඉන්න population එකේ සමාන chance එකක් දෙනවා sample එකට select වෙන්න. හැබැයි non probability sampling අපි කරන්නේ probability law එකට අනුව නෙමෙයි sampling කරන කෙනාගේ දැනුම population එක ගැන. එතකොට අපි හැම individual කෙනෙකුටම සමාන chance එකක් ලබා දෙන්නේ නැහැ sample එකට select වෙන්න. අපි අපේ දැනුම අනුව අපි අදහස අනුව අපි pick කරගන්නවා හරි මේ individuals ටික ගත්තොත් ඒගොල්ලෝ population එක represent කරයි කියලා. So there are some steps of doing non-probability sampling associated with different methods, right? And there is a science, statistical science, or mathematical science behind different methods of probability sampling, right? But usually, so when we do experiment for external purposes, so that to convince everybody, we go with probability sampling methods. But if you do work for our internal purposes, right? So there is no harm of using non-probability sampling methods. So if you talk about sampling methods, so we need to understand few terminologies in detail. The first one is target population, so which is the set of all units that comprises the items of interest in the scientific study. But there are certain instances we do not have access to every individual in the target population. උදාහරණයක් විදිහට අපි යුද්ධ කාලේ අපි අලි ගැන ස්ටඩි එකක් කරනවා නම් උතුරු නැගෙනහිර පැත්තේ ඉන්න අලියෝ අපිට බලන්න යන්න බැරුව තිබ්බා. හැබැයි අපි එහෙම කියලා අලි ගැන ස්ටඩි කරන්නේ නැතුව ඉන්නවද? නෑ, ස්ටඩි කරනවා. What we did was, so we studied about elephants, taking the elephants in the areas where there is no woo. So with this, right, the term sample population is connected. So sometimes there are certain parts of the population for which we do not have access, or they are not available for sampling. Then what we do is we will define the portion of the population, so where we get the sample. That portion is called sample population. The sampling unit is a member of population on which we take measurements, so which is called sampling unit. The sampling frame is a list of individuals in the population. The sample support is mostly useful when we do field experiments. So in the field we get a big sample, so from which where we make small samples in the laboratory. That big sample is called the sample support. So this is sometimes known as the composite sample. The measurement protocol is the procedure that we make measurements, and the sampling design is the design, the sampling method, sample size, right? All these things, the measurement protocol, all these includes in the sampling design. Okay, so this is about the different terminologies. Okay, let's try to talk about, so in this discussion mostly focus on talking about the probability sampling methods. So I have given here 4 commonly used probability sampling methods handling some practical situations in the field. So these sampling methods are respectively simple random sampling, systematic sampling, stratified random sampling, and cluster sampling. So first I will take the simple random sampling and explain you what we will be doing there. Simple random sampling. So we usually apply simple random samples to a population where there is less variation in our measurements. So usually we will employ simple random sampling for a homogeneous or equally likely population, the less variable population. So if you do so, the efficiency of sampling is very high. But when the variability of our measurements is very high in the population, if you want to maintain accuracy, so we need to maintain high sample sizes. So in this case, we will give each and every individual in the population an equal chance to be selected into the population without restrictions. The selection may be done with replacement or without replacement. The usually samples obtained from a table of random numbers or computer random number generator. අපිට සාමාන්‍යයෙන් අපි ඔයගොල්ලෝ Google search එකක් ගහලා බලුවොත් different samplers are there. So we can use such sampler to make samples. එහෙම නැත්නම් අපි කරන්නේ අපිට ඕන lottery එකක් අදිනවා වගේ කරන්න පුළුවන්. lottery එකකින් කරන්නේ simple random sampling එකක්. So we will label our individuals and put all labels into a box and take the number of individuals to sample in a random manner. This can be done either with replacement or without replacement. So with replacement, one individual get more chances, right, to be selected, right? More number of one individual gets more chance of appearing, right? More number of appearing in the sample. But with replacement, an individual get only one chance to be appeared in the sample. No repeated measurements. All right. So this is the way how we accommodate simple random sampling. As I said, right? So in this case, if we want to accommodate simple random sampling, we must have a sampling frame, right? We must have a sampling frame. Right? So otherwise, right, so we cannot label them properly. We cannot label them properly. Okay? But there are certain instances so where we do not have a sampling frame. So in a situation like that, we can accommodate systematic sampling. Or there are certain instances we don't have a clear-cut idea about the total sample size. We have only rough idea. For an example, if you say we want to do the customer satisfaction survey, or we need to do a customer survey, right? අපිට customer survey එකක් කරන්න ඕන නම් අපේ customer base එක මෙච්චරයි කියන අපිට අදහසක් තියෙනවා, but we don't have exactly an idea. So what would be the exact number? ඒ වගේම we don't have a list of customers. So in a situation like that, so we will accommodate the systematic random sampling. So in this case, so we will denote the sample size by simple n and the population size by the capital N. This should be right. So in this case, what we do is we will sample individuals, right, at equal intervals while picking the first person randomly from the population. So this is what we do. So then අපි කරන්නේ අපි ගාව ඉන්නවන මිනිස්සු 1000ක් ඒ 1000 පෝලිමට පෝලිං ගස්සලා එක්කෙනෙක් රැන්ඩම්ලි තෝරගෙන එතන ඉඳන් සමාන ඉන්ටර්වල් වලින් අපි මිනිස්සු තෝරගෙන යනවා. So this is the way how we accommodate systematic sampling. So in this case, we need to understand, so what would be the interval where we do sampling? අපි interval එක define කරන්නේ sample size එකෙන් population size එක බෙදපුවාම අපිට interval එක එනවා. So we take that interval as simple k. So then what we do is, we will sample individuals at kth interval starting from a randomly selected point from the population. උදාහරණයක් විදිහට ගත්තාම අපිට හිතන්න මිනිස්සු 64ක population එකක් තියෙනවා. අපිට sample size එක ගන්න ඕනේ 8යි. එතකොට අපි කොච්චර interval එකකින්ද කරන්න ඕනේ 64 8ෙන් බෙදපුවම 8යි. So we will pick someone randomly. We will pick someone randomly from the population. අපි එක්කෙනෙක් pick කරා randomly, right? මෙයා randomly pick කරා කියන්නකො. 1 2 3 4 5 6 7 8% අපි ගත්තා. Right? ඒ වගේ අපි තෝරගෙන යනවා. So that would be the way how we do select. Okay. Right. So this is called systematic sample, which is mostly applied when there is no proper sampling frame. අපි සාමාන්‍යයෙන් කස්ටමර්ස් එකක් කරනකොට අපි අදාළ ආයතනයට ගිහිල්ලා නැත්නම් ෆුඩ් සිටියට ගියා කියන්නකො. අපි එතෙන්ට ගිහලා we will select the first customer randomly and interview, and thereafter we will say the interval is 20. Thereafter we will pick, right, customers at 20 intervals, the 20th customer, the 40th customer, right, the 60th customer, like that we will be collecting it. And there are certain instances, right, there is a particular variable so that influence our data, our measurements. For an example, so suppose we want to measure the suppose we want to measure the carrying capacity of a set of population. So if you want to measure the carrying capacity of a population, so we get some issues, because the carrying capacity depends on the gender. Gender is one other characteristic, so which influence our measurements, so which is the carrying capacity. So if we get more males into our sample, our estimations will be overvalid. If we get more females into the sample, our estimates will be undervalid. So this is a problem. So if we take a random sample, we have a chance of getting more females into the sample or more males into the sample. So this is a problem. So in a situation like this, what we do is we divide the population into two strata, one strata for male, the other strata for female, right? And we divide the sample size proportionate to the number of males and the females in the population, right? And thereafter, so we will take that number of males randomly from the male population and other number of females randomly from the female population. So this type of sampling method is called stratified random sampling method. Stratified random sampling methods. All right. So there is another way, there is another situation. Although we have selected the random samples, simple random samples, or stratified random samples, there are situations we find difficult to administer it. Sometimes if we get a simple random sample, there may be a person in a hilly area where we don't have access to collect data. There may be a very tall tree, we have less. So there may be extreme things like that, which refrains us administering the data collection process. In such a situation, so we will divide the population into clusters depending on the geographical orientation of the population. And we will sample using simple random sampling or any other sampling technique. So from the clusters to get representative samples from each cluster. So this is called cluster sampling. So this is mostly done to facilitate the data collection process, to make the data collection data collection process easy. But the advantage with cluster sampling is, so we need to maintain high sample sizes to get the accuracy. All right, so we discussed the methods of data collection. And this concludes our lecture today. Happy? Any question? අපි ඊගා දවසේ we will be talking about summary statistics, right? In two categories: descriptive summary measures, numerical summary measures and graphical summary measures. In the next class. All right. Any question after this? No questions or yes questions? Anybody?
Excuse me, sir. Do you upload this presentation today?
Yeah, definitely. I will do it.
Thank you.
Okay. Any other questions? So if you do not have questions, okay, we will stop the class at this point and we will see you in the next class. The date will be notified soon. Right. Okay, we will see you.